This question is about the reflection of a point through a plane. So let P be the point 1, 0, negative 2, and pi be the plane x plus y minus 2z plus 3 is equal to 0. P prime is the reflection of P in the plane pi. Find the coordinates of the point P prime. So if you look over here, I have a diagram, and when you reflect the point P through the plane, you're creating a mirror image on the other side of the plane. So the distance from P to A is the same as the distance from A to P prime, and you're basically dropping a perpendicular from P down to the plane and going straight through. So P to P prime forms a straight line through the plane that is also normal to the plane. Now, to find the reflected point P prime, we're going to find the equation of the line starting at point P and going in the direction of the normal of the plane. So to do this, we can get the normal of the plane from the equation, where the normal of the plane is equal to 1, 1, negative 2. We already have the point P, which is 1, 0, negative 2, so we can get the equation of the line. Let's use x, y, and z. X, y, z is equal to the point 1, 0, negative 2 plus the direction t, and the components of the direction vector are the normal to the plane. So 1, 1, negative 2. Now what we have to do is find the point A that intersects with the plane over here. And since this line that we just made represents the line from P to P prime, then we can find the point A by just plugging in the parameter, plugging in this equation into the equation of the line. So let's change this to the parametric equation. X equals 1 plus t, y equals 0 plus t, and z equals to negative 2 minus 2t. And we'll plug these points into the equation of the plane, which is x plus y minus 2z plus 3 is equal to 0. And plugging these three parameters in, we get 1 plus t minus 2 times negative 2 minus 2t plus 3 equal to 0. And let's solve for t. So we have 1 plus t plus 4 plus 4t plus 3 is equal to 0. 1, 2 plus 4t is 6t, and we have 1, 4 plus 3, which is 8, is equal to 0. 6t equals to negative 8, and t is equal to negative 4 over 3. So the point A corresponds to the t value of negative 4 over 3. So if we come back to the diagram here, point A represents the parameter t equals negative 4 over 3, and point P over here represents the parameter t is equal to 0. Because if you plug t equals 0 into the equation of the line over here, you'll get the point P. So if from t equals 0 to t equals negative 4 over 3, you get from point P to point A. Well, to get from point A to point P prime, you just have to double this parameter, this t value, because the distance from P to A is the same as the distance from A to P. So the parameter for P prime is t equals 2 times negative 4 over 3, which is equal to which makes t equal to negative 8 over 3. So now we just have to find the coordinates of point P prime, and we do this by plugging t equals negative 8 over 3 back into this equation over here. So we have the equation x, y, z is equal to 1, 0, negative 2 plus t 1, 1, negative 2. And with t is equal to negative 8 over 3 that we have over here, we can find the coordinates of x, y, and z for the point P prime. So actually we can just use this the parametric equation that we already created. X is equal to 1 plus t, so x is equal to 1 plus negative 8 over 3, and we get x is equal to negative 5 over 3. Y is equal to 0 plus t, that you can see over here. So y is equal to 0 plus t, y is just equal to negative 8 over 3. Z is equal to negative 2 minus 2t. Z is equal to negative 2 minus 2 times negative 8 over 3. Then we get z is equal to 10 over 3. So therefore the coordinates of point P prime are negative 5 over 3, negative 8 over 3, and 10 over 3. And that's how you find the reflection of a point through a plane.